Hi, my name is Nico Stuurman. I work at a light microscopy core at a startup called Altos Labs, but I'm talking now about a project that I started in Ron Vail's lab at UCSF about 18 years ago, helping develop open source software for microscope control. So when we think about microscopes in cell biology, it ranges from these sleek built systems like this Zeiss microscope on the right that comes with software to custom built systems like this lattice light sheet, or what we were often using, kind of a combination of the two, something commercial but with some add-ons. And software control became super important. Back in the day when we started, software for microscope was not that great. And we really needed and wanted something that we could use and that we could use in our experiments to build and design better systems. So we proposed at a lab retreat to start a open source microscopy software project back in 2004, a graduate student, a postdoc, and I. And when I now look back at that proposal, it's kind of cool. We wanted the software to benefit a much larger community than just our lab. And I think we managed to do that. We wanted to develop using ImageJ, have it as a plugin of ImageJ. We thought writing code controlling the microscope and other hardware would be straightforward. And our time estimate was like, 1 to 3 months part-time with 3 people. So you clearly need some optimism to jump into projects like this. Luckily, Ron liked this idea, and he helped recruit Nenad Amodai, who had experience in industry, to do something like this. And we got a small grant from the Sandler Foundation at UCSF. And Nenad came up with this design consisting of an abstraction layer that abstracts the hardware and that talks in the top to a plugin, the micromanager interface in Java, and at the bottom to the actual hardware. So the great thing of that bottom interface is that it let hundreds of different developers write code to interface different kind of equipment into micromanager. At the moment, for instance, all the scientific grade cameras are supported by developers from the companies making the cameras. And this has really been the big success story of micromanager. So well separated interfaces are important. And then what I didn't tell is that interface is written in C++. And C++ as a language really gives longevity. I am sure that all that code still can be built 20 years from now and will continue to help everyone. The user interface, which Nenad called Micromanager Studio, has all the stuff that you need to operate a microscope, snapping an image, etc. And APIs were developed for that later on, especially by Mark Tsushida. So Mark also developed a data viewer, and that data viewer has its own API and is extremely important because while you are acquiring data, you really need a pleasant way of interacting with the data, seeing your histogram, manipulating the histogram, etc. And to be honest, the micromanager viewer, I think, is still one of the nicest open source ones. And I really would like to see a way of giving that back to the community at large. You need data storage. Mark also developed a data storage API, and Henry Pinkert did great work developing code writing our data to disk in a multi-page TIFF format. And writing data is also kind of tricky because it needs to be fast, because cameras produce data at high speeds, and you want it to save in a format that can be used in multiple other environments. Other component here is what we call the acquisition engine, which basically is a way of translating a protocol of how the user would like the experiment to proceed into something that can interface with the hardware. And Arthur Edelstein wrote one of these, and Henry actually wrote another one. And then a plugin interface so that you can extend everything that is there. And one of the last projects that I worked in is a plugin that did automated FREP, find cells, find subcellular components, and photo bleaches it, and then even calculates the recovery curves. But many other people, including Jérôme Deschamps here, from the EMBL, have contributed plugins. This EMU plugin gives you like nice control of other types of hardware, or John Daniels from the company ASI, who wrote this DyeSpin plugin that controls light sheet microscopes from ASI. Then you can also script and interface with Micromanager from other environments. As we all know, we are moving in the image analysis world from liking Java because of ImageJ to Python. The Napari project has now given a comfortable viewer and has a plugin mechanism. And Telly Lambert and his co-workers used PyMM Core, a module that exports the Micromanager core to Python, maintained by Mark Tsushida, and used that to write a interface from Napari directly to Micromanager. Another way of interfacing with Micromanager was developed by Henry Pinkert, and Micromanager is a bridge that interfaces with Micromanager, which has the advantage that you also get access to all the goodies that live in the Java layer. Support with projects like this is extremely important. So first thing is an installer. There are installers on Windows and Mac that makes it extremely simple to get the application to actually run, which a lot of projects have problems with. We started out with a mailing list that is now moved to the image.sc forum, from which we provide support, people with questions. And then the website itself, it started out as a wiki and is now moved to a GitHub Pages-based system. And that port was done by Curtis Rudin and Sam Griffin. And now everyone can contribute to the whole documentation. And so also the documentation is a community effort. Micromanager is widely used. Here, this graph shows the growth of the number of publications mentioning Micromanager, and the publications that we put out were cited more than, almost 3,000 times by now. We started with small grants from the Sandler Foundation, and then had 7 years of NIH funding. That NIH funding is difficult to continue, and it definitely is hard to keep a project like this funded with public funds continuously. We tried in a company format, both in 100x imaging and open imaging, but that it's also quite difficult to find a decent business model that supports open source software and is viable enough. And Mark continued working on Micromanager at the University of Wisconsin in the group of Kevin Ellis-Seri, supported for a while by a grant from the CZI, and the CZI is really doing wonderful work in this realm. Now, there are all kinds of interesting trade-offs in projects like this between having maintainable software or really making a cool new feature work, etc., etc. And I'm super happy to talk about that. And I hope you'll ask me questions, or happy to talk in any other forum that we happen to see each other. So with that, I want to just shortly mention all the different people who contributed. And a very important person here is Ron Vail, who really started this off, made this happen. We had an idea and he really put that into reality. Many people from the Vail lab over the years have contributed as beta testers, or coming up with the name and general support. We had quite a few people who worked directly on Micromanager within at UCSF. And I consider them all great friends. And then there are so many people who have contributed code or have contributed documentation or helped support the software in both at universities and in companies. And to me, that has been a wonderful experience to work with all of these people. And with that, I'd like to open it for questions. If I can stop the recording.